Hello, let's do the New York Times Medium Sudoku for May 5th, 2024. There's a link in the description if you'd like to try the puzzle yourself or follow along with me. And I'm going to get started right now. So let's go over some terminology first. This is a cell. There are 81 cells in the grid. And then this is a row. This is a column. This is a box. Only the bold outlined region boxes are boxes, not like something like this. So we have 9 boxes in the puzzle. Basically, we're calling out things where there are 9 cells that cannot repeat, right? So the rows, the columns, boxes. This is a band. A row of 3 boxes is a band, and this is a stack. A column of 3 boxes is a stack. I'm going to be using those terms. Okay, so what we're going to do is we're going to start by going band by band. We're going to look at the 3 bands one at a time, and we're focused mostly on what's going on within the band itself. That's how we're going to start. So the first thing we're going to look for in the band is whether there are any digits that appear twice in the band, exactly twice. We don't care about once, we don't care about 3 times. The way we're going to find that is we need to compare each box against each other box. And so I'm going to start with the box that has the fewest givens in it. That's this 5 and this 9 here. I'm going to look to see if there's any 5s or 9s in these other 2 boxes. So we do have the 5, we don't have a 9. So these 2 5s are going to do something. They look into this other box and say, we can't have more 5s in this row or this row. So the 5 in this box has to be in one of these 3 cells only. And we know that the box needs a 5 because every box needs 1 of each digit. And so the 5 is going to end up in one of these 3 cells. Obviously not where the 2 is already occupying. So the 5 actually ends up in one of these 2 cells. So what we want to do is we want to remember that we discovered that the 5 is limited to these 2 cells. And I'm going to use the corner marks for that. So I'm going to use the corner mark mode. This is what center marks look like. This is what corner marks look like. So when we use corner marks, what it will always mean is that within this box, that digit has been limited to the cells that it's marked in, and only the cells that it's marked in. It's an exhaustive list of cells in the box that can be 5. And so that way, if we ever say eliminate one of these 5s, for example, then we'll know that the other one must be 5, right? We'd have a hidden single 5. So nothing to do with this yet, but we are notating it so in the future we will remember. So that does the 5, 9. Now we just compare these 2 boxes against each other. I'm going to start with the one with the fewer givens. We have the 1, 2, and 6. 6 is the only one that has a buddy. So these 6s look over, and all 3 of these could be 6. So we're just going to corner mark that there. All right, before we move on to the next band, because that was all of the... Oh, no, sorry, we also have the 1s repeating. I don't know how I missed that. So the 1s are also down here. So now that we have all the repeats, before we move on, we want to look for 2 things. One is a completely filled row within a box. So this is almost, right? We have the 3 and the 6, but we don't know what this digit is. So this isn't filled. This isn't filled. So we don't have any completely filled rows in the box. And we're also looking for any rows or boxes that are down to 4 or fewer open cells. So for example, this row here is down to 5 open cells. It's close, but it's not quite there. So we don't actually have any of those in this band. So we're just going to move on. So we're looking for a duplicate 4 here. We do have a buddy for this 4. Now here, we can see that 4 has to be in one of these 3, but the 3 and the 6 are occupying 2 of the spots. So actually there's only one place left in this box that can be 4. It's the highlighted cell. So it must be 4 because the box needs a 4. And if we didn't put the 4 there, then we wouldn't be able to put the 4 anywhere and we would have broken the puzzle. So that's called a hidden single. Hidden, that word hidden always means that we're talking about a row, column, or box and something about it, right? So a hidden single is saying there's only a single cell in the box in this case that can be 4, so it must be 4. Okay, so any other repeats? So we looked at this 4. We want to look at 3, 6. We don't have any other repeats. Now, before we move on, remember we're looking for a filled box row. Here we go. This box row is filled. So what are we going to do with that? We're going to look at all of the all of the cells that are not in that row and not in that box. So it's going to be 12 cells here. The ones I've highlighted for these 3, it's the ones I've highlighted. We don't care about empty cells, and we don't care about cells that contain digits we don't care about digits that are already in the box. So really it's just the 7 that we care about. But what this 7 is going to do is it's going to look into this box and remove the 7 from these 3 cells. You can kind of imagine that we have a 7 somewhere over here, like a virtual 7, an imaginary buddy for our 7 that took the 7 out of these 3. And so these three can't be 7 and this can't be 7. You kind of imagine it's the same thing as if we had a buddy. So we're going to end up penciling 7s down here. But now I'm going to prove that the 7 over here that we imagined is actually real and always will be. So the reason for that is pointing. So what's happening here is we have limited the 7 in this box to these 3 cells, which means that one of these 3 cells in the final solution will be a 7. So what does that mean? Well, no matter where it ends up, it will be in row 6. It'll be in this row. So row 6 can't have another 7 in it. If I try to put a 7 over here somewhere, like say here, then I won't have anywhere to put 7 in this box because I've eliminated all 3 of the potential locations. So no matter where this 7 ends up, if it ends up here or here or here, it's going to remove 7 from these cells and these cells. So that's called pointing, because if we sort of draw a line between all the candidates in the box, all the cells that could be 7, we draw a line through them, that line continues to the rest of the row. It kind of points at the rest of the row. That's why it's called pointing. So these can't be 7, these can't be 7, and our virtual 7 that we said would be over here is actually over here. And so that's why we look for this. So that gave us a non-trivial deduction, which is that these 3 cells cannot be 7, and these corner marks are going to try to remind us of that. Okay, last thing we want to look for is a row or a box down to 4 or fewer cells. We do not have that, so we're going to move on. All right, now we look for buddies here. I'm going to use this 9-3. We do have the 3. The 3's got a buddy. This 3, and we do look up. I haven't done that. I haven't had to do that yet because there hasn't been an example. But we do want to look up and just see if there's any 3s that are helping out up here. So you're just looking for 3s. We have these 2 3s looking down. So really that means that there's only one place left for 3 in this box. So we can place the 3. All right, there's no buddy for the 9. So now we're going to look at the 1 and the 2. We do have a buddy for the 2. This 2 helps out, removing 2 from here. So there's a 2 in one of these 2 cells. That's it for repeats. We do have a filled box row. So we're going to look at these again. And we don't care about the 3 or the 2 or the 3 or any of these empty cells, but the 1 and the 9 are both helpful. Take them one at a time. So this 1 is going to have a virtual buddy 1 in one of these 2, because we do have this 1 up here. Taking it out of that cell, it's going to be the one. It's going to be the in line with the filled row, because we're imagining that we have a 1 over here, removing a 1 from there, and then we're going to end up with a 1 here. So we can just corner mark those right away. The 9 is going to do the same thing, but we're going to have a buddy 9 up here somewhere, and then the 9 does end up here as well, and this 9 says not there. So we can corner mark the 9s there as well. All right, nice and quick once you get used to how that works, right? You can just put all the corner marks in all at once. And that's it for the filled box row. Any rows or boxes down to 4 or fewer cells? I'm not seeing any, so we're going to move on. And the next step is to do the exact same thing we just did, but rotate 90 degrees. So we're going to do it with stacks. And anytime I said row, we're going to say column instead. So we're going to start with this first stack here. I'm going to look for a duplicate 3 or 9. I do see a duplicate 9. So we have a 9 in one of these 2 cells. Oh, yeah, sorry. I didn't notice that we had this 9 over here, but it actually does place the 9 in this box. We have these 2 looking in. This is not 9, and this 9 says that's not 9. So 9 is placed in the box. Now, as soon as we place a digit, what we want to do is we want to follow up. And by follow up, the most important things to look for are things that we already scanned for earlier. So we already scanned this band. But when we did so, we didn't know this cell was 9. Now we do. So we want to follow up on the 9 to see if that changes the story for any of the things we looked for already. So it has this buddy 9. And so now 9 in this box is actually placed. We can place that 9. And that does remove this corner mark 9. So we can just do that right away. What else did it do? Well, it filled this box row. So we can look at all of these cells, and we don't care about the empty cells. We don't care about the 9s. We don't care about the 1 or the 5. Okay, so none of those are helpful, but it was worth looking. And then any rows or boxes down to 4 or fewer cells. Yes, this box is down to 4. So what do we do when we find that it's down to 4? Well, what we want to do is think about what are those 4 digits. And then we want to think about whether those are restricted in some way. I'm already seeing this 2 and 4 are going to do it, but the digits that we need to look for are 2, 4, 7, 8. And I'm seeing we have this 2, 4 right here. So if these 2 cells can't be 2, 4, because the 2, 4 is already in the column, and we need a 2, 4 in the box, we're left with these 2 cells being 2, 4. And I'm going to use center marks to denote that. What we found here is a hidden pair in the box. What center marks mean in our notation is that for this cell, these are the only possible digits that can go in that cell. In the final solution, this cell will be a 2 or a 4, and this cell will be a 2 or a 4. Guaranteed. Now, the reason I know that is we need to place a 2 and a 4 in this box, and these are the only two cells that can be. So they must be. Very similar to a hidden single, but we're taking 2 digits at a time into 2 cells. And so because the 2 and 4 are over here, they're not over here. So what are the 2 digits that are left? That's the 7, 8. We can just fill the 7, 8 pair there. Hopefully that makes sense. Okay, so we haven't scanned this stack yet, so we don't really need to worry about following up with that. Otherwise, I would have. We're trying to take things one at a time here to be instructive. So are there any other rows or boxes down to 4 or fewer here? No, there's not. So now I'm done following up on the 9. So that was this 3, 9. It's important to remember what you were doing, or just go back and try to rescan what you can. Okay, so now I'm going to compare this 4, 7, 9 up here. We already took care of the 9. 4 and 7 do not have buddies. So we're out of buddies. Are any box columns filled? No, they're not. Are any columns or boxes down to 4 or fewer cells? No, they're not. So we can move on. We move on to this stack here. Now, these pairs that we have, this 2, 4 pair, the 7, 8 pair, the columns do not care how they resolve, right? This will be either 7, 8 like this, or it'll be 8, 7 like this. Those are the two options, and the column doesn't care. All the column cares about is that now we know the 7 and 8 are up here. So first of all, I can remove this corner mark 7. I should have earlier as soon as I place this. But also, they can count as buddies, right? So if I look for 1, 2, 3 here, we do have all 3 3s, but the 2, sorry, let's do the buddy 1 first. These ones look in. There's a 1 in one of these 2. The 2 does have a buddy. It's up here somewhere. We don't know exactly which cell it is, but there's a buddy 2 up there. So we can put a 2 in one of these 2. The important thing to remember is that 2 and 4 are up here, so the rest of these are not 2, 4. 7, 8 are up here, so the rest of these are not 7, 8. Very similar to pointing, except we have 2 digits at once doing it. All right, so that was the 1, 2, 3. We also have the 3, 4, 6. 3 is already taken care of. 6 does have a buddy. So we're going to put corner mark 6s here. The 4 has a buddy in the 2, 4 pair. So this 4 looks down, the 2, 4 pair looks down, and this 4 looks in. This 3 is not a 4. So there's actually only one cell in this box that can be 4. So we have a hidden single 4. We can place it. Now follow up on the band. So we have a buddy 4 over here. This 4 looks down, puts a 4 in one of these 2 cells. Okay, anything else to follow up on? We did not fill up a box row. We caused this row to be down to 4. So let's think about what it needs. It has 1, 2, 3, 4. So it needs 5, 6, 7, 8. Neither of these cells can be 8. So these are down to 5, 6, 7. And this one can't be a 5 because of this 5 up here. So anytime I find that a cell is down to 3 or fewer candidates, I'm going to center mark it. If it's ever more than 3 candidates, 4 or higher, I will not center mark it because that's just clutter. But by center marking these, we're giving ourselves a chance to find pairs and triples, naked pairs, naked triples. Okay, so now over here, we needed 5, 6, 7, 8. Is there anything restricting that? As far as I can tell, there is not. We do have the 7, 8 pair here, actually, so that is very important. So this can only be 5, 6. So now the question we want to ask is, where does 8 go in this row? Remember this 7, 8 pair here? The 8's somewhere up here, which means this can't be an 8. And then this 8 said these can't be 8. So in this row, we need an 8. This is the only cell that can be. You could also see this naked 5, 6, 7 triple if you wanted. Either way, we place this 8. Now follow up, because we did do this vertical already, and we did this horizontal. So horizontally, these 8s do look in. It does place this 8. That filled up a box row, so we do want to look for things. So we have the 9 marked already, 3 and 8. 4, 8, 3, 2. Okay, so nothing super special about that. Vertically here, there's not much to do with this 8. Anything really to do with the 8, so I'm going to ignore that. We filled this box row, so the 2 we already have marked. 3 is in the box, 8's in the box. 4 we have marked, 8 and 3. Okay, just double checking. Now this box is down to 4 open cells. So what are they? They are the 5, 6, 7, 9. We know that this can't be 7. So this is, sorry, I think I said something wrong. 5, 6, 7, 9. Yeah, okay, this can't be the 7. So this is 5, 6, 9. This can't be 5, 6, or 9. Look at that. This cell can't be 5, 6, or 9. Those are 3 out of the 4 possible digits. So this has to be the 7 because it needs to be a value. It can't be 1, 2, 3, 4, 5, 6, 8, or 9. Or we can use this 8 even. So if it can't be any of those, that's 8 out of the 9 total digits. So this is what we call a naked single, because nakedly you just look at the cell, there's only one digit it can be, so it must be that digit, which is the 7. It doesn't matter that this could have also been 7. I get this question a lot. How could you possibly place this 7? In the box, there are 2 places for 7. So how could you know which one it was? And the answer is, this cell needs to have a value. It cannot be 1. Look. It conflicts with all these 1s. It can't be 2. It conflicts with this 2. Cannot be 3. Cannot be 4. Cannot be 5. Cannot be 6. It could be a 7. Cannot be 8. Cannot be 9. There was only one digit it can be, so it must be, because we're not going to leave any cells empty. So it is a 7. It doesn't matter that this couldn't be 7, or that this could also be 7. It doesn't matter that that could also be 7, right? So hopefully that's clear. So that is a naked single 7. We place that 7. We want to follow up if we can. We can follow up by saying, well, now it's got a fake buddy, right? It's got a virtual buddy down here. So there's a 7 down here, and that means there is a 7 over here. Okay. Really, this 7 looking and this 7 looking down tells you there's a 7 one of these two, and we know there's a 7 one of these two as well, as a result. This is down to 5, 6, 9. It's not a 6, so 5, 9 only. Okay, I've reduced this column down to 2 digits. Usually, whenever you see that, you want to kind of just think about it right away because it can always be helpful. It's very usually helpful. We need 2 and 8 left. So that 2-8 pair might be helpful pretty soon. I'm noticing that this is the only place for 7. We removed the 7 here. I didn't place it. So we can place this 7 in the box. The only place for 7 in the box. This box is now down to 3 digits. Why do I say it's down to 3? What about these two? Well, we know these are 2 and 8. One of them will be 2, one of them will be 8. It doesn't matter how it resolves. The rest of the box doesn't care. The rest of the box says I can't be 2, 8. And so the remaining digits are the 1, which goes over here. We have the 2, 3, 4. We need 5. We have 6, 7, 8. We need 9. Right. We knew that this column also needed 5, 9. So I could have done that as well. Okay. So I don't think there's anything else to do in this stack. I think this stack is kind of taken care of for now. Let's make sure we followed up on this band properly. So no more rows or boxes down to 4 or fewer. Yeah, I think that's all we get out of that for now. Okay, so what was I doing? I was scanning this stack, I'm pretty sure. So we have one more stack to scan. Let's do it. So this 4 does have a matching buddy. So we have a 4 in one of these two. Now we have this 5 and 9. No buddies. Any filled box columns? No. Any columns or boxes down to 4 or fewer? No. Okay, so we finished our first pass on bands and on stacks, and we didn't quite finish. So the next thing that I'm going to do is I'm going to go box by box, and I'm going to see if I missed anything a little bit more detailed, a little more subtle. So I'm going to be paying attention to just in general how digits are restricted in the box. Mostly what I'm going to be looking for are what I call crossings. So for example, I have this 1 and 6 here, right? I don't think I'm going to actually, maybe I should try to find a crossing. Do I have any? Not in this box. Okay, well, so I'm paying attention to this 1, 6 here, right? Any pair of givens such that they're, let's actually use this 1, 9 because I can do something with it. So I'm looking at a pair of givens that share a row or column, right? So this 1, 9 shares a row. And I'm looking at the one column they don't occupy, right? Because they share a row, they're in 2 different columns. There's going to be only one column within that stack then that they don't occupy. And I only care about digits that aren't already in the box. So the 7. And I just want to see what that 7 does, right? First of all, I look for 7s over here. I don't see any. But I am seeing that this 7 looks up here. And these happen to be filled. So there actually are only 2 places in this box that can be 7. So I may as well corner mark that. I'm going to be looking at all sorts of, like, a lot of that, where, like this 1, 6, I'm going to look over here. And I've got the 3. So the 3 looking in, and I do have this 3 looking up, but it doesn't help because it lines up with the 1, 6. So if I had a 3 over here somewhere, that would be very helpful. But unfortunately, I don't. So this is what I'm on the lookout for. The other thing I'm kind of noticing about this box, and I think this is a good thing to be noticing as you go box by box, is I have the 5 and the 7 corner marked here, and they're avoiding these 2 cells. Now remember, I like to center mark cells that are down to 3 or fewer, and these are guaranteed to be 3 or fewer, because there are only 5 open cells in the box, and the 5 and the 7 are not here. So 5 minus 2 is 3. So what are the 3 digits? Well, they're going to be the 3, the 4, not 5, 6, 7, and 8. So 3, 4, 8. Not immediately helpful, but maybe in the future. So this box, we're not going to find anything internal because we already basically know how the box is. The 7, 8's here, the 2, 4's here. So we're going to move on to here. Are there any crossings? Well, the 2 and the 4 could potentially cross. And the 2 actually does. So this 2 goes in, looks in, and this 2 looks in. Now that you see why I call it a crossing, because we have these 2's crossing into the box, and they're crossing in front of this 5, 9. They avoid it. And so that leaves only 2 cells left in this box that can be 2. And that's very powerful, because that's always going to do something called pointing. We already went over pointing, but it's always going to do pointing. So the 2 ends up in one of these 2 cells. Whichever one it ends up in, it will be in this row. So that means this cell cannot be 2, because the 2's over here. So this cell can't be 2. If it can't be 2, there is only 1 digit left it can be, which is the 4. So I can place that as a 4. And that does place the 2 here. Now placing that 4 does remove this corner mark 4. Now there's only 1 corner mark 4 left in the box. We place that. This 4 also looks left, removing this 4 for what it's worth. Okay, so follow up on 4s. The 4s have a buddy. This 4 looks up. There's only 1 place left in this box for 4. That's why we follow up. We can place the 4 here. That looks down, removing this 4 corner mark. That places this 4, which removed a 7 corner mark. That places this 7. That removed this 7 corner mark, which places this 7, which removed a 5 corner mark, which places this 5. This box needs 3 and 8. I know this can't be an 8, so this is the 3, this is the 8. That resolves this 7, 8. This row has only 1 open cell. Whenever you notice that, always good to just fill that digit. That's a 7. That removes this from being a 7. This is down to a pair. Always good to notice that when you can. This is down to 1, 8. This 8 tells us the order. So this is the 1, this is the 8. This can't be 1 anymore. Up here we have a triple. It is the 2, 3, and 6. We can clean that up a little bit. We don't need the corner marks anymore. The center marks tell us all we need to know. All right, so this top band is basically done. We definitely want to follow up on what we got here. And I think because these boxes got filled, especially this stack could be useful to at least look at. So the 4, 9, and 7 are actually all done. So there may not be much to see there, but we do have the 3 and the 8. So the 3 has a buddy. Yeah, that places the 3 in this box. Let's follow up on that real quick. These 3's look in, so that places the 3. That places the 6, 2, and 3. Very nice. All right, we'll follow up on that stack in a moment. Let's come back to this stack here. So we had the 3. We also had the 8. The 8's got a buddy, right? So the 8's in one of these 2. Now, this is a little bit advanced, but I want you to be on the lookout for this when you can. It is a hard spot. But if you can spot it, it can be very nice to spot. Okay, so what am I talking about? Well, I just corner marked 8's in here. And what I did is when I did that, I noticed that they're kind of aligned vertically, right? The 8's are avoiding this row, is what I'm trying to say, right? The 8's are aligned vertically and they avoid one of the rows. And all I did was I just scanned right and I looked to see if either of these boxes tell the same story. And this box does. This 2-8 pair tells us that the 8 is also limited to the same 2 rows in this box. Well, if the 8's are in this box, how many 8's, right? How many 8's have I accounted for? I've accounted for 2 of the 8's. And both of those 8s can't occupy this row, right? So they're going to occupy these 2 rows. So where's the 8 in this row is really the question you can ask. And the answer is not in this box, not in this box. The 8 in this row is in this box. If you think about it, if the 8 ends up here, it'll have a buddy here. Otherwise, the 8 will end up here and it'll have a buddy here, right? So we have buddies always looking in like this, no matter how it resolves. This 8 looks in, so we end up with an 8 in one of these 2. Oh, sorry, we also have this 8 looking down. So that actually places 8 for the row, really. Places 8. And that removed a corner mark 7. That places a 7. That gives us this 6 and this 7 and this 5 and the 6 and the 9. So that's a 5. I told you it would be powerful. Cool. So all that cleans up. We are almost done with this puzzle. When you feel like you're almost done, my recommendation is to just, if you want to finish it up a bit more quickly without doing all the systematic stuff, if you have a lot of rows, columns, boxes down to 4 or fewer, just start looking at those and look at the one that's the most restricted. So, for example, this column here, I already know that this is a naked single. How do I know that? Well, I know that this column needs a 1 and a 2. And I know this can't be the 1 or the 2 because we have the corner marked up here. So I know this is going to be fruitful, right? What do we need? We need the 1, the 2, and 3, 4, 5. We need a 6. And you can see that this is the only place for 6, but also this can't be 1 or 2 because there were corner marked 1s and 2s up here. So this ends up the 6, and we had left with a 1, 2 pair. This row is down to 1, 2. We have the 3, 4, 1, 2, 5. So neither of these are 2. This 2C's here, this 2C's here. So there's only one place for 2 in the row. This is the kind of thing we're looking out for when we pencil. So that's the 2, that's the 1, that's the 2. Very nice. This box just finishes with a 5. That gives us the 1 and the 5 here. This column is what we call a full house, right? It has only 1 digit left. So that's a 6. This box has 2 digits left. What are they? One of them's an 8. So it's 5 and 8. This 5 tells us the order. That's 8, that's 5. That gives us the 2 and the 8. This is down to 1 or 9 for the row, but this 9 says not here. So that's the 1, that's the 9, that's the 1. This 1 gives us this 1 and 9. This box is filled. We just need to place the 5. And then we're down to the 2, 6, and 9. This is the 6. This is the 2. This is the 9. And we're done. So you can see once the puzzle gets kind of near the end, it's really just about marking up the limited rows, columns, boxes, and you'll usually finish up. So cool. There were some neat things to spot in here. I'm glad that we were able to spot the lined up 8s here. That's something you don't always get to see. But really, it's indicative that you have claiming 8s. And in fact, we had a hidden single 8 in this row as a result, which was very neat. So, yeah, hope you enjoyed this. Hope it was useful for you. And if it was, why not leave a like, subscribe, and a kind comment below.